This is the double pendulum example for the GitHub repository on Rust for Sagebox. And when we run it, you can see that we have a double pendulum that swings around with a fading trail and a number of controls to the left that we can use to affect the look and behavior of the pendulum itself. This double pendulum example uses traditional graphics and does not use the GPU, and it runs in a smooth 60 frames per second. When we start it, these instructions here display how to use the pendulum, and what it really amounts to is that we can just grab it and drop it and let it go. And so while it's swinging, we can affect the display by, say, changing the pendulum size, and we can change the rod thickness, and we can also move it up and down by using the right mouse button. We can place any pendulum individually, and we can move it into place and then drop it and let it go. We can also affect the physical properties of the pendulum. So, for example, when I set the bottom weight to a mass of 1,000 and press return, you can see it really reacts like suddenly there's a huge weight on the second pendulum. When we run it, we can check the show timing checkbox, and that'll tell us how much time is being taken to generate each frame. So on my system, it's taking about 3 milliseconds to generate the pendulums and the trail. And since we have about 16 milliseconds to play with, we have plenty of time that we can add things to maintain our 60 frames per second fluid motion. So let's look at some code. Let's go to the Sagebox GitHub page, and then in the examples, we can see the double pendulum project with some information about it. But let's go look at it in VS Code. So in VS Code, we have exactly the same directories, and I'm just going to check the full control one, which is the biggest one of all the progressive ones. So let's look at these controls here to the left and see how they're created. So in the function init controls, this is where we create and initialize all the controls we just saw on the left. So first I create a text widget that's just displays, and then with one line each, I just create the rest of the controls with the sliders and the checkboxes and the radio buttons. So when we run it, we can see all the controls that we just made, including all of the defaults set properly, in about 12 or 13 lines of code. And here's where we set the defaults. We can just make these controls without defaults, but we can use keywords to set the defaults right here. So when it comes to the event handling itself, or processing the controls where I move the slider or I set the pendulum position, let's look at that code. So in the function called handle events is where we look at everything going on in the system. And so the first thing I do is I look at all of the mouse events. So if the mouse is clicked, or if it's in a mouse drag event, which is just holding the mouse down and moving it. And then I call various functions to handle those events. And then I look at the actual control. So here, for example, I look at the input box, and if the return was pressed, I change the weight to whatever the user entered. And then I can look at the slider for the pendulum size and other things. And as you can see, it's really only about 30 lines of code, maybe 25 lines of code, to handle all of the mouse movements and control movements together. So let's go ahead and look at the pendulum code itself. I mean, what math do we use to make the pendulum? I don't really know, because this code here I wrote the structure and the Rust code, but this code right here is code I just got off the internet. So if you search for it, you should find it. But to me, that's really the whole neat thing about it is that we can take code that we find off the internet or from other sources or things in our mind and put them in a small little desktop graphics-based desktop applications like this Sagebox program here. You may remember that in the beginning of the program, we have this set of instructions displayed on the screen. Let's look at how that's created. So you can see we have about 10 or 11 write functions here that we call, and we can set fonts like 12 italic here, and we can set colors like light green, and we can use G for green or P for purple to get the styling that we want embedded in the text, so we can just do it all on one write line. So when we run it, these lines of code we just edited produce this display for our instruction. So now let's look at the real-time display in the upper left that's displaying things as the pendulum moves around. So in our display values function, we have all of these write functions out to the window, and you can see where it says x equal 130. So when we run it, this is why everything's lined up on the right, because we set the x value to 130 midline, and we also change the color in the same text line, so it really makes it simple to write. So the C and the G that you see in the curly braces just represent changing colors to cyan and to green, respectively. Let me show you what these two lines are about. We have two more write lines that are based on an overflow, and this happens when we don't have any dampening, and the floating point just has exceeded its resolution. It just gets finer and finer to the point where it just gets out of control. And the program detects that and will print out a message letting you know about it, that you should change the dampening control. So I'm just going to try to get this to overflow here. And you can see I've turned the dampening down, and it definitely is getting out of control. So in a couple seconds, it'll overflow, and we'll see the message print in the bottom left part of the screen. Okay, this is taking longer than I thought, but it will happen anytime. Okay, we can see it getting out of control, so it's definitely going to print a message to us. And this is just There it is there. There's the message right there. And that's the floating point overflowing because it just cannot handle the resolution. And so the code looks for any overflow greater than 2. It doesn't care about a couple. And then it'll print a message saying you should look at the dampening. And so it's just a really nicely formatted message and just a couple white lines. So that's really the overview of the double pendulum example in Sagebox for Rust. It is a program that runs in traditional graphics, non-GPU graphics at 60 frames per second pretty fluidly, and is a great example of doing kind of more of a mathematical base for a program for research or education or just for fun.